Hi everyone, and welcome to this series of circuit practice problems. And this is second question about transient analysis. So let's see the question. It says here in the question, you need to find V0 of T or V output of T across this 10 kilo ohm resistance as T is greater than or equal to 0. Okay, so as we did before, the first step that you do, that you assume that the answer, your V0 of T is equal to K1 plus K2 E minus T over tau. So that is the first thing you do. Number two, you solve for T less than 0 and you assume that the switch was long enough at that position so that here the inductor is fully charged. Now the inductor fully charged, so now we are interested to find IL at 0 negative, meaning that before we basically change our switch position. So here we have 4 milliamps. We have here 10 kilo ohm, another 10 kilo ohm, and now the inductor will be basically a short circuit because it's fully charged. So the 4 milliamps will come here, it will split to here and there. So this is your basically your IL at 0 negative. Your IL at 0 negative using current division is equal to 4 times 10 kilo divided by 10 plus 10, and this will give me 2 milliamp. So this is the current basically at T less than 0. Now at T equal to 0, your IL at 0 minus is equal your IL at 0 plus. So the moment you close the switch, because the current cannot change instantaneously through the inductor, the current will be exactly the same, which is equal to 2 milliamps. Okay. Now we need to find or to solve for my V0 or V output at this 0 moment is equal to what? So now I need to solve for T equal to 0. So the switch now is moving in that direction, and the inductor will be actually modeled as a current source going in that direction, because this is the direction, the current that is going here in the T less than 0. So there are 2 milliamps, and then we'll have here 10 kilo, and here's the output voltage that I am interested to find it at 0 plus or at 0. This is your 10 kilo ohm, and this is your 20 volt. So I can use nodal. Nodal looks very nice to use it. So this is your basically your V0 at 0 plus. So your apply KCL at V0 0 plus at this node. Assume this current is leaving, this current is leaving, and this current is entering. So basically V0 at 0 plus minus 20 divided by 10 kilo plus V0 at 0 plus divided by 10 kilo equal to 2 milliamp. I will multiply everything times 10 kilo. Then you will have here V0 at 0 plus minus 20 plus V0 at 0 plus. This is equal to 20. Move this one here, becomes 40. So your V0 at 0 plus is basically equal to 40. To V0, then your V0 at 0 plus is equal to 20 volt. So that is the voltage at the T basically equal to 0. Now let's go at T goes to infinity. At T goes to infinity, now this inductor will be going back to as a short circuit. This is your V0 at infinity. This is your 10K, 10K, and this is your 20 volt. Okay, so we need to find V0 at infinity. Now, very clearly that this voltage source does not really, the voltage source here does not do anything this 10 kilo because this 10 kilo is short circuited, as you can see here. So obviously your V0 at infinity is basically equal to 0 volt. So now we know V0 infinity, we know V0 at 0. The last thing is basically your time constant. So then you will find R Thevenin. So the R Thevenin will be between the two terminals of the inductor. So this is your R Thevenin. This is 10 kilo. Now we don't have any dependent sources here, so we just short circuit this. So it's very obvious here that your R Thevenin is 10 kilo in parallel with 10 kilo, which is equal to 5 kilo. Now the time constant is equal to L over R. The inductor is 1 millihenry divided by 5 kilo. So this will give me 0.2 times 10 to minus 6 seconds. That is basically my time constant. Now let's go back here. My V0 of t is equal to K1 plus K2 e minus t over tau. Okay, so V0 at infinity is equal to 0, and this is equal to K1. So your K1 is basically equal to 0. V0 at 0, this is equal to K1 plus K2. And we found this is equal to 20. So this is equal to 20. So it means that your K2 is equal to 20. We have the time constant. Then we are set. Your V0 of t is basically equal to Q1, which is equal to 0. K2 20 e minus t over 0.2 times 10 to minus 6, or equal to 20 e minus 5 times 10 to plus 6 times t. So that is basically your V of t in volt. So this is the function of the voltage across this resistance.